teacher Neth, and welcome back to our statistics and probability class. Since you know by now how to make a sampling distribution of the sample means, then we may move to determining the mean and the variance of a sampling distribution. It is but important to acquaint yourselves first with the terms and formulas related to this topic. Sampling distribution of sample means have properties. These are the following. First, the mean of the sampling distribution of the sample means mu sub x bar is equal to the population mean mu. That is, mu sub x bar equals mu. That is, the mean of the sampling distribution of means is equal to the population mean. This happens since all samples obtained of n size are obtained from the same population. Second, the variance of the sampling distribution of the sample means sigma squared sub x bar is computed by variance of the sampling distribution of sample means equals sigma squared over n, small letter n, or the sample size, times n, capital letter N, or the population size, minus small n, or the sample size, all over n, capital letter N, the population size, minus 1. For finite population. That's for finite population. And for infinite population, we have variance of the sampling distribution of means equals sigma squared over n, small n, the sample size. It has to be noted that population variance is greater than the variance of the sample means, since a sample size of n is less than the population size n. Third, the standard deviation of the sampling distribution of the sample means, that is, in symbols we have sigma sub x bar, is given by standard deviation of the sampling distribution of sample means equals sigma over square root of small n times square root of the quotient of n, capital N, minus small n over capital N minus 1 for finite population, where square root of n minus n over n minus 1 is the finite population correction factor, which is not used when capital N is large and small n is small, as it will be very close to 1. And by standard deviation of the sampling distribution of sample means equals sigma over square root of n for finite population. It is also called as the standard error of the mean. So, the standard deviation of the sampling distribution of sample means is also called as the standard error of the mean. It reveals how accurate sample mean is as an estimate of population mean. Let us have examples.
Example, Teacher Amy, an araling panlipunan teacher, conducted a survey on their senior high students. Based on the data she gathered, she found out that only a few were aware of who Hermano Pule is. That is, only 1, 2, 3, and 4 students from 4 sections knew his biography. Suppose that the sample size of 2 sections were drawn from this population without replacement. Describe the sampling distribution of the sample means. First, let us solve for the mean of the sampling distribution of the sample means. And this is the formula to use. Mu sub x equals mu. This mu in the right-hand side of the equation refers to the population mean, which is also the same as summation of x over n. Since what we have in the given problem are the values of x and the value of n, then we may use this fraction for us to solve or to know the value of the population mean, or mu, which is also equal to mu sub x. So by substitution, the values of x are 1, 2, 3, and 4. So we get their sum. Their sum is 10. and then divide it by the population, which is equal to the 4 sections, and what we get is 2.5. That means approximately there are two students who know the biography of Hermano Julio. Now, for the variance of the sampling distribution of the sample means, this is the formula to use. Sigma squared sub x is equal to sigma squared over n times n minus n over n minus 1. Sigma squared here means the variance of the population. Capital N still is the population. Small n refers to the sample size, and 1 is a constant. Since we do not have the direct value for population variance in the problem, then we will substitute to this sigma squared its equivalent. Summation of the square of x minus mu, or summation of x minus mu squared over n, the population. Okay. For us to solve for this part, x minus mu squared, let us first list down in the table the values of x. That's for the first column. We know from the previous slide that the values of x are 1, 2, 3, and 4. And then for each, we will solve for the value of x minus mu. The mu in the previous slide is 2.5. So for the first, x minus mu is 1 minus 2.5. That is negative 1.5. For the next, when this x is 2, then this is 2 minus 2.5, which is negative 0.5. So that is what we'll do. Also for x equals 3 and for x equals 4, these two x's. Then still the value of mu is 2.5. We have computed for the value of this already. So this is what you'll have: negative 1.5, negative 0.5, 0.5, and 1.5. Since what we want to get in the formula is the square of it, then in the third column, let us write the values of this when squared. So negative 1.5 squared, you may use your calculator, that is 2.25. Negative 0.5 squared is 0.25, 0.5 squared is 0.25, and 1.5 squared is 2.25. Then what does the formula tell us to do? To get the sum of all these values. So we will get the sum of these values, get their total, and that is equal to 5. Again, from this formula, by substitution, this is what we'll get. We've known that the value of the summation is 5 over the population, which is 4. So the numerator in this formula now becomes 5/4 over the sample size, which is 2, times population minus sample over population minus 1. So that is 4 minus 2 over 4 minus 1. Then what we did here is we divide 5 by 4 and we get 1.5. But in other solution, of course, this may be solved in another way. In other ways, this may not be converted first to decimals. This may remain as is, a fraction, and then later we'll arrive also at the same answer. But this time, since this is what we have chosen as our solution, then I've converted it to a decimal number. So this is 1.25 over 2 times 4 minus 2 is 2, and 4 minus 1 is 3. And then from this, we can see that we have common factors, which is 2. Then you may divide this. 2 divided by 2 is 1, or their common factor is 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. Then 1.25 divided by 3 is 0.42. Or if you did not notice that you may cancel this out, or what the right term for that is, we may get the lowest term of this. For example, you did not notice that, you may multiply 1.25 by 2, and then divide their product by the product of 2 and 3. Still, you'll arrive at the same answer, 0.42. Now, for the standard deviation of the sampling distribution of the sample means. This is the formula or the symbol for that standard deviation, and that is equal to the square root of the variance of the sampling distribution of the sample means. Since from the previous slides, we've known the value of this, the variance, so the standard deviation is equal to the square root of 0.42, the value of this variance. And that is, use your calcu and you'll get 0.65. This is when it's rounded to the nearest hundredths place. So the standard deviation of the sampling distribution of the sample means is 0.65.
Meanwhile, let us talk about the distribution of the sample mean for normal population. When the population variance sigma squared is known, the standard deviation of the sampling distribution of sample means, or the standard error of the mean, is derived by sigma sub x bar equals sigma over square root of small n, where sigma sub x bar is the population standard deviation and small n is the sample size. To determine the probability of certain event, we can use z distribution or the formula z equals x bar minus mu over sigma over small n over square root of small n, where x bar is the sample mean and mu is the population mean. This best applies for large sample sizes, for instance when n, small n, is greater than or equal to 30. When the population variance sigma squared is unknown, the standard deviation of the sampling distribution of the sample means, or the standard error of the mean, is derived by s sub x bar equals s over square root of small n, where small s is the sample standard deviation, or the point estimate of the population standard deviation sigma, and small n is the sample size. To estimate the population parameters, we use t distribution or the formula t equals x bar minus mu over s over the square root of n. We use t distribution for small sample size, for instance when n is less than 30. Take note that as small n gets very large, small s gets closer from sigma, or from the population standard deviation.
Example 2. This equation is, given population mean of 85, a sample of 35 has a standard deviation of 1.1. In this example, the population variance is unknown. What are given are the population mean and the sample size, but not the population variance. And if the population variance is unknown, then the standard deviation of the sampling distribution of the sample means, or the standard error formula, is the same as the means or the sample standard deviation. And the formula for that is s sub x equals s over square root of n. Example 3. The situation is, inspired by MCGI Free Store, teachers in a school put up their own free store for their learners. They have recorded a population variance of 1.13 among senior high school learners with 6, 7, 8, 9, and 10 family members who were recipients of the community outreach program. Samples of size 3 are drawn from this population. The population variance in this equation or problem is identified. Population variance is 1.13, so that is known. And if the population variance is known, then the standard error formula is the same as the population standard deviation, which is mu sub x equals mu over square root of n.
I hope you understood the examples. While we practice objectivity in solving for the mean, variance, and standard deviation, the sampling distribution of the sample means, incorporate equity. It is an ingredient of social responsibility. Until next time,